Angle relationships in circles. Our objective is to find the measure of angles formed by lines that intersect circles, as well as use angle measures to solve problems. Who uses this? Circles and angles help optometrists correct vision problems. Let's look at a formula. If a tangent and a secant, or chord, intersect a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So very similar to a previous section, if we have arc AB, that is going to be twice the size of angle ABC. Let's look at an example. Find each measure. The measure of angle BCD. BCD. Well, your arc is BC, and since the arc is 142, we're simply going to take half of that, which will leave us with 71 degrees. Now, if we want the measure of arc ABC, we know that angle ACD is 90, so we need to double it, which will give us 180 degrees. Let's look at another formula. If two secants or chords intersect the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. Essentially, you're taking the average. So if you add arc AB and arc CD together and then divide it by 2, you'll get what angle 1 is. Keep in mind that AEB and CED would be the same measure because they're vertical angles. Let's look at a couple of examples. The measure of angle SQR. So we're looking for this angle right here. It's important to make sure you know which angle you're looking for, because every once in a while it might ask you for angle PQS, for example. So you'll have to go one step further. Either way, we're going to take the average of our two angles, or arcs. So we have 100 degrees plus 32 degrees, and then we're going to take half of that. And when we do so, we end up with 66 degrees. Try this next one on your own. Now that you've had a moment to try this next one on your own, let's try it together. So we're going to add our two arcs together. So we have 65 plus 37, and then we'll take half of that. So when we do so, we end up with 51 degrees. These next formulas are similar to the last one, only because the angle measure you're trying to find is outside of the circle, instead of adding and then dividing by 2, you're going to subtract the smaller arc from the larger arc and then divide by 2. So for example, the measure of arc DA minus the measure of arc BD, divide that by 2, and you will end up with the measure of angle 1. That will work for any of these if the angle is on the exterior. Let's try an example. We'll do this first one together, and then you guys can try the next one. So we have the measure of x, which would be 1/2 of the larger angle or larger arc minus the smaller arc. So 174 minus 98. And we're going to take half of that, and that will leave us with x. So 174 minus 98 divided by 2, 38 degrees. All right, take a moment and try this next one on your own. Now that you've had a moment to try this next one on your own, let's try it together. Notice they didn't give you the larger angle measure, but you can figure that out. You know a circle is 360 degrees, and EHG is just whatever's left over after you subtract 132. So when you do 360 minus 132, you end up with 228. So this exterior arc out here is 228. Now you can plug your 228, your 132, and your x into your formula. So we have 228 minus 132, and then we're going to take half of that, and that will give us what x is. In this case, x is 48 degrees. Let's try a real-world application. When a person is farsighted, light rays enter the eye and are focused behind the retina. In the eye shown, light rays converge at R. If the measure of arc PS equals 60 and the measure of arc QT equals 14, what is the measure of angle PRS? So PS is 60 degrees and QT is 14 degrees. It wants us to find this angle measure. So 1/2 times 60 minus 14 will give us 23 degrees. Let's look at a few more formulas. Now, if your vertex of the angle is on a circle, half the measure of its intercepted arc. So this is 120, angle 1 will be 60. If this is 200, angle 2 will be 100. The inside a circle, half the sum of the measure of its intercepted arcs. So if you add 44 and 86 together, divide that by 2, you'll end up with the measure of angle 1, which in this case is 65 degrees. Outside a circle, this is what we were just doing. Half the difference of the measures of its intercepted arcs. So 202 minus 78 divided by 2 will give us the measure of angle 1, which in this case is 62 degrees. Or you might have 125 minus 45, divide that by 2, that will give you the measure of angle 2, which is 40 degrees. Try this example. Find the measure of arc LP. So you're looking for this arc right here. Take a moment and try it on your own. For this, we can look at the measure of arc MS, the measure of arc PR, and the measure of angle Q, which is 26 degrees. So if we take our larger arc, subtract our smaller arc, divide that by 2, we'll end up with our exterior angle out here. So in this case, we have 80 minus your unknown, divide that by 2, equals 26. So we can multiply both sides by 2, so we end up with 80 minus x equals 52. Then we can subtract 80 from both sides of the equation. We end up with negative x equals negative 28, which means x equals positive 28. And since the measure of arc LR is 100, we can simply take 100, subtract what PR is, which is 28, and we end up with 72 degrees. And that concludes our lesson on angle relationships in circles.